Hi friends, in this video I want to analyze and design a separate footing by Geo5. We have two layers of soil, that is the thickness of first layer is 3.5 and the density is 1.925 gram per cubic centimeter. Also we have the saturated soil density and internal friction, cohesion, poisson ratio, oedometric modulus. We have the same parameters for the second layer. Also from the dimensions we have a depth of original ground surface, depth of footing bottom, foundation thickness, inclination of finished grade, which is 5 degree, and inclination of footing bottom 9 degree, unit weight of overburden, which is 21 kilonewton per meter cubic. Also we have design load and a service load, and basic dimensions, which is include XY and column dimension, separate footing, rotation. Also we have some data for material of footing, which is concrete and reinforcement. Also the ground water table is given, which is 4.7 below the ground surface. We have this data and we have to use all of this data in the program. Let's open the program Geo5. That's all the codes for pile group, also for abutment, for beam, cantilever wall, earth pressure, but we want to, and also slope stability for slab, but I want to use separate footing CPT and separate footing. When we use separate footing CPT, when we have the result for CPT test, but we don't have the result of CPT test, so we use separate footing. Okay, takes a while. Oh, that is the appearance of the Geo5. So first of all, from project it, we write the task. The task is analyze analysis and design separate footing. Also part you can write description, you can descript of the task, customer for who you do this task, and system of units. We have English and metric, we use metric. Also who did the design, I write my name. Okay, that's the date, project ID and project number, you can put it. Also from setting and add to administrator, we have separate footing. Analysis if for drained condition I use Eurocode. For undrained condition also Eurocode. Analysis of separate footing on rock subgrade Eurocode. You can choose others, but I use Eurocode. Also analysis of uplift I use standard. Allowable eccentricity, the program uses 0.33 as a maximum eccentricity. I use the same. Verification methodology, you can choose. I use safety factors. Okay, safety factor for vertical bearing capacity is 1.5 and safety factor for sliding resistance 1.5. Factor of safety uplift is 3. Okay, add and close. From profile, we have to input the thickness of the layers. The thickness of first layer is 3.5 and the second layer is 2.5. Let's put it. Okay, depth of interface thickness of layer, I use thickness of layer 3.5 at, okay, 2.5, no, we have to delete this one, remove, yes, okay, yes, the first layer 3.5 and the second layer 2.5. From soils we can add the soil 1, okay, gamma or unit weight is 1.925, which is equal to 19.25 kilonewton per meter cubic. Angle of internal friction is 28, and cohesion of soil is 10. Poisson's ratio of 0.15. Okay, and oedometric modulus 15.1. Okay, use standard. Gamma saturation is 20.25. Also, we can change the color for the soil. I use this color for soil 1 at second soil 2. The density is 2.05 gram per cubic meter, which equal to 20.5 kilonewton per meter cubic. And the angle of internal friction is 20. Cohesion is 35. Poisson's ratio 0.15 as it is, and oedometric modulus is 16.3. Okay, and gamma saturation is 21.5. And change the color. Let us put this one. Okay, now we provide soils. Also, we have to assign the soil. First layer we have to provide soil 1, and for second layer soil 2. Also here let's provide soil 2. And foundation. From foundation we have to first choose the type of spread footing. That's all the type of spread footing. Eccentric spread footing and centric footing, centric spread footing with steps, but we have centric spread footing. Okay, let's provide this data. Okay, depth from original is 3 meters. Depth of footing bottom 1.95, and foundation thickness is 0.5. Inclination of finished grade 5. Inclination of footing bottom is 9. 5, and this one is 9. Okay. Also, the unit weight of overburden is 21. Yes. Okay. And load. Add. We have design load and service load. Load number 1, vertical forest design load, 1050. Sorry. Okay, bending moment in direction X is 20. Try to bend the foundation. And My is 18. Horizontal force HX is 5 and this one is 13. Okay. Load number 2 is service. Service load, which is vertical force 785.87.5 and moment is 10.8 and My is 3. And horizontal force is 4.5 and Hy is 11.7. Okay, that is the two load which we have. Also from geometry we have to input these values. Overall dimension is 1.9 and overall dimension is Y is 2.1 and Cx column dimension, which is a component of superstructure, is 0.5, 0.5 and spread footing rotation is 0. Dimension design, we talk about it later. Okay, footing bottom. You see, that is the inclination of the footing. Here we have an ability to input parameters of contact base soil. If we have the data for friction between the base footing and the subsoil, we can put it from here, but we don't have the data, so we leave it as soil from geological profile. Sand gravel bed also we can provide the property if there is a sand and gravel beneath the footing. So from here we can change this length. If we change it to 1 meter, you see, and also from height we can change the height from here, and also we can assign the type of soil 1 or soil 2 but we don't use here for, and take this one. Okay, also from here we can see in 3D, that is the 3D, you can see it in 3D format or okay, let us put the material. Unit weight of concrete, you can, if you have, you can use, or we don't, I don't have, so approximately concrete is 24, 23, we use as program, let's use it 23, and from here if you have the properties you can input the property which you have, but I use from catalog. Okay, type of concrete is C16/20. It is the concrete grade. It means that the concrete has the strength of 16 megapascal in 28 days. Okay, this one. And for longitudinal reinforcement, we have B428. Check. Yes. Okay. And for this one, transverse reinforcement, the same. Surface recharge. You can from here you can add recharge, but I don't have recharge, so surcharge. So I leave it. And groundwater subsoil. Let us provide groundwater. Groundwater is 4.7 meter below the surface. Okay, 4.7. Yes. This incompressible subsoil, that's the groundwater, and as you see, incompressible subsoil, this help us to determine or to limit the F calculation. If we have a rock layer below the footing, when you provide the calculation for bearing capacity and settlement will be at that limit, so you don't use it. Okay, earthquake, we don't use earthquake. Stage setting, don't use it. Bearing capacity, just by one click you can find the bearing capacity. Shape of contact stress rectangle, most unfavorable load number 1. That is the important. Designing bearing capacity of foundation soil is 876.14. That's the program calculated the bearing capacity, and the stress, which is the force provided stress for the footing, is 313.89. That is the bearing capacity of the soil, and that is the applied stress. So the bearing is a factor of safety will be the RD divided by sigma, which equal 2.79, which is greater than 1.5, which is a factor of safety. So bearing capacity in the vertical direction is satisfactory. Also, eccentricity in x direction is 0.07, which is smaller than 0.333. Also, in y direction, eccentricity is smaller than the allowable eccentricity, and overall eccentricity is smaller from the allowable eccentricity. So eccentricity float is satisfactory. Horizontal bearing capacity check, because the soil is inclined, final ground surface is inclined, and also the bottom of the foundation is inclined, so we have a force horizontally. Horizontal bearing capacity is 398.28, 698.28, and also the extreme horizontal force is 13.93. The factor of safety will be this RDH divided by H, which it equal to 15.13, which is too much greater than 1.5. So bearing capacity in the horizontal direction is satisfactory. And also you see we provide 2.1 length and 1.9 width, but the contacted area is 1.87 instead of 1.9 and 2.06 instead of 2.1. That is because of eccentricity. Also, here we can find the bearing capacity for load 1. You see there's a little change, but we use maximum values. Okay, and also earth resistance for passive at rest or 1/3 passive. That is all another option is for finding the bearing capacity, but we use at rest. Okay, regarding settlement. Foundation stiffness. Average modulus of deformation is 15.06. Also, vertical float eccentricity, all is satisfactory. And that's important. Foundation settlement is 12.8 millimeter, and depth of influence zone 4.28. The foundation is effected till the 4.28 meter below the footing. That is the settlement. Okay, and the rotation in direction of x is 8.5 multiplied 10 to the power minus 4, and in rotation in direction of y is 1.6 multiplied 10 to the power minus 2. It's so small. And also from geometry we have a dimensionless design. You see, we have bearing capacity which is 2.79. It's greater than 1.5, but we have an option for optimization for footing. So program suggests for us a smaller size of footing, so it suggests 1.5 and 1.40 is enough. Okay, let us examine the bearing capacity. You see now bearing capacity is 1.53, which is greater than 1.5 and satisfactory. Also, it influences about a settlement. Okay. Settlement now. At first time it was 12 point something millimeter, but now it's 18.6. It depends on serviceability. This limit is acceptable or not. Depth of influence zone is 4.4. Okay, and also regarding from dimensioning we can find that is the reinforcement is okay or not. As we see here, longitudinal reinforcement is not okay in direction x. Also longitudinal reinforcement in direction to y is not okay. Why? Because required area of steel is 822.6, but there is 804.2. So we can solve this problem by providing greater bar diameter, or by adding more number of bars. So put 6 number of bars or 5. Okay, 5 number bar is good in x direction, also for y direction. Yes. Now the steel bar is good. Verification. So longitudinal reinforcement in direction x and direction y is good. Punching shear also, it is good. That is all. I hope it is be helpful. Have a nice time.